Intel Many Integrated Core Architecture or Intel MIC is a coprocessor computer architecture developed by Intel incorporating earlier work on the Larrabee Many Core Architecture, the Teraflops Research Chip Multicore Chip Research Project, and the Intel Single Chip Cloud Computer Multicore Microprocessor. Prototype products codenamed Knights Ferry were announced and released to developers in 2010. The Knights Corner product was announced in 2011 and uses a 22 nanometers process. A second-generation product codenamed Knights Landing using a 14 nanometers process was announced in June 2013. In September 2011, the Texas Advanced Computing Center announced it would use Knights Corner cards in their 10 petaflop Stampede supercomputer, providing 8 petaflops of computing power. At the International Supercomputing Conference, Intel announced the branding of the processor product family as Intel Xeon Phi. In November 2012, Intel formally announced the first product citing claims of CPU-like versatile programmability, high performance and power efficiency. The Green 500 list placed a system using these new products as the most power-efficient computer in the world. In June 2013, the Tianyi 2 supercomputer at the National Supercomputing Center in Guangzhou was announced as the world's fastest supercomputer. It utilizes Intel Ivy Bridge EP Xeon and Xeon Phi processors to achieve 33.86 petaflops. History, background. The Larrabee microarchitecture introduced very wide SIMD units to AX86 architecture-based processor design, extended to a cache-coherent multiprocessor system connected via a ring bus to memory. Each core was capable of 4-way multithreading. Due to the design being intended for GPU as well as general-purpose computing, the Larrabee chips also included specialized hardware for texture sampling. The project to produce a GPU retail product directly from the Larrabee research project was terminated in May 2010. Another contemporary Intel research project implementing x86 architecture on a many multi-core processor was the single-chip cloud computer, a design mimicking a cloud computing computer data center on a single chip with multiple independent cores. The prototype design included 48 cores per chip with hardware support for selective frequency and voltage control of cores to maximize energy efficiency, and incorporated a mesh network for interchip messaging. The design lacked cache-coherent cores and focused on principles that would allow the design to scale to many more cores. The Teraflops Research Chip was an experimental 80-core chip with 2 floating-point units per core implementing not x86 but a 96-bit VLIW architecture. The project investigated intercore communication methods, per-chip power management, and achieved 1.01 TFLOPS at 3.16 GHz consuming 62 W of power. Knights Ferry, Intel's MIC prototype board, named Knights Ferry, incorporating a processor codenamed Aubrey Isle, was announced May 31, 2010. The product was stated to be a derivative of the Larrabee project and other Intel research including the single-chip cloud computer. The development product was offered as a PCIe card with 32 in-order cores at up to 1.2 GHz with 4 threads per core, 2 GB GDDR5 memory, an 80 MB coherent L2 cache, and a power requirement of 300 W, built at a 45 nm process. In the Aubrey Isle core, a 1024-bit ring bus connects processors to main memory. Single board performance has exceeded 750 GFLOPS. The prototype boards only support single precision floating point instructions. Initial developers included CERN, Korea Institute of Science and Technology Information and Leibniz Supercomputing Center. Hardware vendors for prototype boards included IBM, SGI, HP, Dell and others. Knights Corner. The Knights Corner product line is made at a 22 nm process size, using Intel's Tri-Gate technology with more than 50 cores per chip, and is Intel's first many-cores commercial product. In June 2011, SGI announced a partnership with Intel to utilize the MIC architecture in its high-performance computing products. In September 2011, it was announced that the Texas Advanced Computing Center will use Knights Corner cards in their 10 petaflop Stampede supercomputer, providing 8 petaflops of the compute power. According to Stampede, a comprehensive petascale computing environment, the second-generation Intel MICs will be added when they become available, increasing Stampede's aggregate peak performance to at least 15 petaflops. On November 15, 2011, Intel showed an early silicon version of a Knights Corner processor. On June 5, 2012, Intel released open-source software and documentation regarding Knights Corner. In June 2012, Cray announced it would be offering 22nm Knights Corner chips as a coprocessor in its Cascade systems. In June 2012, ScaleMP announced it will provide its virtualization software to allow using Knights Corner chips as main processor transparent extension. The virtualization software will allow Knights Corner to run legacy MMXSSE code and access unlimited amount of memory without need for code changes. The Knights Corner chip was announced as being rebranded as Xeon Phi at the 2012 Hamburg International Supercomputing Conference. Tianyi 2, the world's fastest supercomputer according to the TOP 500 list for June and November 2013, utilizes Xeon Phi accelerators based on Knights Corner. Knights Landing, codename for the second-generation MIC architecture product from Intel. Intel officially first revealed details of his second-generation Intel Xeon Phi products on June 17, 2013. Intel said that the next generation of Intel MIC architecture-based products will be available in two forms, as a coprocessor or a host processor, and be manufactured using Intel's 14 nanometers process technology. Knights Landing products will include integrated on-package memory for significantly higher memory bandwidth. Knights Landing will be built using up to 72M on cores with 4 threads per core, support for up to 384 GB of DDR4 RAM and 8 Euro 16 GB of stacked 3D MCDRAM. Each core will have two 512-bit vector units and will support AVX512 FSIMD instructions with Intel AVX512 conflict detection instructions, Intel AVX512 exponential and reciprocal instructions, and Intel AVX512 prefetch instructions, along with Intel's full x86 instruction set except TSX. Knights Landing's TDP will range from 160 to 215 AW. Xeon Phi. On June 18, 2012, Intel announced that Xeon Phi will be the brand name used for all products based on their many integrated core architecture. On September 11, 2012, it was announced that a supercomputer called Stampede would be based on the Xeon Phi. Stampede is capable of 10 petaflops. On November 12, 2012, Intel announced two Xeon Phi coprocessor families, which are the Xeon Phi 3100 and the Xeon Phi 5110P. The Xeon Phi 3100 will be capable of more than 1 teraflops of double-precision floating-point instructions with 240 GB per second memory bandwidth at 300 AW. The Xeon Phi 5110P will be capable of 1.01 teraflops of double-precision floating-point instructions with 320 GB per second memory bandwidth at 225W. The Xeon Phi 7120P will be capable of 1.2 teraflops of double-precision floating-point instructions with 352 GB per second memory bandwidth at 300W. The Xeon Phi uses the 22nm process size. The Xeon Phi 3100 will be priced at under $2,000 while the Xeon Phi 5110P will have a price of $2,649 and Xeon Phi 7120 at $4,129. On June 17, 2013, the Tianyi 2 supercomputer was announced by TOP 500 as the world's fastest. It uses Intel Ivy Bridge Xeon and Xeon Phi processors to achieve 33.86 petaflops. An empirical performance and programmability study has been performed by researchers. The authors claim that to achieve high performance Xeon Phi still needs help from programmers and that merely relying on compilers with traditional programming models is still far from reality. Design. The cores of Intel MIC are based on a modified version of P54C design, used in the original Pentium. The basis of the Intel MIC architecture is to leverage x86 legacy by creating a x86-compatible multiprocessor architecture that can utilize existing parallelization software tools. Programming tools include OpenMP, OpenCL, Silk Plus and specialized versions of Intel's Fortran, C++ and math libraries. Design elements inherited from the Larrabee project include x86 ISA, 4-way Summit per core, 512-bit SIMD units, 32 KB L1 instruction cache, 32 KB L1 data cache, coherent L2 cache, and ultra-wide ring bus connecting processors and memory. The Knights Corner instruction set documentation is available from Intel. Competitors: NVIDIA Tesla, a direct competitor in the HPC market. AMD Firestream, another direct competitor in the HPC market. See also, AVX 512, Cell, Intel Tira Scale, References. External links, Intel Pages, Xeon Phi Product Family, Hazra, Raj, Intel registered trademark Xeon registered trademark Phi-Cent coprocessors accelerate the pace of discovery and innovation, blogs.intel.com, today. With the announcement of Intel registered trademark Xeon registered trademark Phi-Cent coprocessors, we unregistered trademark going to accelerate the pace of these discoveries and innovations. Intel registered trademark Xeon Phi products extend the Intel registered trademark Xeon registered trademark brander. Intel teaches Xeon Phi x86 coprocessor snappy new tricks.